Okay, hello everyone, and welcome. Today we're looking at absolute value functions and the transformations of those functions. Okay, today's objective is to transform the graph of the absolute value function. This is the absolute value function shaped like a V. Okay? Today's essential question: what do changes to the absolute value parent function do to its graph? Right, again, the parent function looks like this. It touches the vertex, that's called, that point right there at the origin. All right, just to kind of review, guys, the absolute value symbol, it's a function. It makes every number positive. So the absolute value of -3 is actually 3. And the absolute value of 3 is also 3. All right, it's a positive distance from 0 on a number line. That's how it's defined. It's distance. It measures magnitude, how far, not direction. It does not measure direction. It doesn't care which way. All right, it's always positive. How far, what distance, okay? As the parent function of the absolute value, it's the simplest function of a family of functions. It preserves the shape of the entire family of functions. And again, the absolute value parent function, it looks like this: y equals the absolute value of x. All right? If it was just y equals x, it'd be a straight line coming all the way down. But once x gets negative, it turns positive, okay? As the vertex of the graph, it's the maximum or minimum point of the function, okay? It's where it changes direction there, that point at the bottom or the point at the top if it's upside down. It can be an upside down V as well. Guys, a translation, it's a shift of the graph, horizontally, vertically, or both. Right? It kind of slides it around. Okay, the result is a graph of the same shape and size, it's just in a different position. It moves the vertex to a different place. A reflection, on the other hand, is when the graph is flipped upside down. All right, the result is a graph of the same shape and size but pointed in the opposite direction. A reflection is just where we put the negative in front of the absolute value. So the final answer is always negative. All right, now that's the upside down V. Now the expanded absolute value equation looks like this. All right, this is what you need to know. The H is the thing that moves the graph left and right, back and forth, left and right. The thing that's inside the absolute value symbols near the X. All right, the K moves the graph up and down. The K is the thing that hangs out on the end outside the absolute value symbol. All right, the A is the multiplier. It's multiplying times the function. It sits in front of the absolute value symbol and multiplies the X and the H if it's distributed. All right, again, the A makes the graph wider or narrower, thinner, or it flips it upside down. The A, it's kind of like a slope. Guys, as an example, all right, this says 2 in the front here. That's the A. Inside the absolute value symbol is x minus 3. And then outside here it says minus 2. So let's look at each one. The 2 makes the graph narrower. It goes up twice as fast. So instead of up 1 over 1, it goes up 2 over 1. It goes up faster, twice as fast. So it makes the graph narrower. It has a slope of 2 instead of 1. Now the 3 moves the graph 3 units to the right. It's important to understand that 3 units to the right. All right, remember inside here, this says x minus h. So 3 here is actually a positive 3. That's why we move it to the right. Think of this. Inside the absolute value symbol, you move the opposite of what the sign says right here. This says negative 3. That means you move 3 in the positive direction to the right. Now the red negative 2 is different. Negative 2 does mean move down negative 2. That is what that means. Negative 2 means move down 2. So I move down 2. So you see what happens here. We move to the right 3 and down 2, and that's where our new vertex is. At the point 3, negative 2. Get another example here. The blue negative symbol is what flips the graph upside down. Again, that just means negative 1 in front. So the slope is negative 1, and down 1 over 1. Down 1 over 1. All right, so it doesn't make it narrower or wider. It just flips it upside down. All right, the plus 2, again, moves the graph to the left 2. Plus 2 on the inside, near the x, inside the absolute value symbol. You move in the opposite direction from what the sign says. That says plus 2, so I move back 2. All right, to the left 2, toward the negative 2. All right, outside this plus 3, the red 3, that means you move up 3. All right, outside is exactly the same. The opposite of what's inside, the same as what's outside. Exactly what it says outside. Plus 3 moves up 3. So again, our new vertex is negative 2 plus 3. That's our new vertex, the slope of 1, and then it mirrors the other side. Okay, sorry guys, I had to get rid of some of that. Guys, next you can go ahead and complete the homework check. These are the vocabulary words for today. Okay, you can look them up in the slideshow and get the answers. All right, that's it. Thanks.